Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the condition for negative specific heat. So you can see that we have already derived this formula, which is the formula for specific heat for a polytropic process, and we know that if you can see that if n is greater than 1, then this term would be positive, and if this term r upon n minus 1 is greater than r upon gamma minus 1, then specific heat will be negative. And we can also say that gamma minus 1 should be greater than the n minus 1, and gamma should be greater than n. So if n is less than gamma and if n is greater than 1, then the specific heat of this process would be negative. And negative specific heat means that we would need to withdraw some amount of heat from the gas to increase its temperature instead of giving the heat to the gas. Normally we do give some heat to the gas to increase its temperature, but if the specific heat of the gas or the process is negative, then it means that we need to withdraw some amount of heat to increase the temperature of the gas. And you can see that if this n is greater than 1, then the slope of this graph, obviously pv to the power n is equal to constant, will be a hyperbolic graph. So if n is greater than 1, then the slope of this graph would be greater in magnitude as compared to the isothermal graph. So this graph would be below the isotherm, and obviously if n is greater than gamma, then slope of adiabatic would be greater than the slope of this polytropic process in magnitude. Therefore we can say that the negative specific heat process will lie between these two graphs, which is first is isothermal process and this one is adiabatic process. So any graph which is lying between these two graphs and which is a hyperbola will be a process of negative specific heat, and it means that we need to extract some amount of heat to increase the temperature of the gas. Thank you.